All right, find the derivative of y equals 5x minus 2 over x squared plus 1. So we have here the quotient of, we have y written as a quotient, and so we're going to apply the quotient rule. So for functions that can be written as y equals f of x over g of x, the quotient rule tells us that y prime, or the derivative, is equal to g of x. Actually, no, before I write it out, I just want to give you the way I learned the quotient rule way back. I mean, this is going back maybe 20 years. The first professor who introduced the quotient rule to me actually sang it in a song, which I'm not going to do here, but it stuck with me, and I've never forgotten the quotient rule since then. And the song went something like this. Let me switch colors here. Low d high minus high d low over low low. And so the way it works is we have the high and the low. The high function is the f of x. It should be h-i-g-h, but I'll just write it h-i. And the low function is the g of x. So the quotient rule says low d high, the low function, g of x, d high times the derivative of the top function minus high f of x, d low, the derivative of g of x, over low low, or the g of x, the denominator, squared. Okay, so there's our quotient rule for derivatives. So we come down here to the problem. Y prime should equal to low d high, or g of x times f prime of x. So low d high, derivative of 5x minus 2. Well, the derivative of 5x is 5, and the derivative of 2 is 0, so that's just a 5, minus the numerator, high d low, so high, the top function, 5x minus 2, d low, derivative of the denominator. So derivative of x squared is 2x, and the derivative of 1 is 0. And this is all divided by the denominator squared. High d low, or sorry, low d high minus high d low over low low. All right, so there's our derivative. So the calculus portion of this problem is done. So let's do some algebra to simplify what we have. So let's multiply through the 5, and let's multiply through the 2x. All right, so we've got 5x squared plus 5 minus 5x times 2x, so that's 10x squared, and minus a minus, so that's a plus, minus a minus 2 times a 2x, so that's a plus 4x, and this is over x squared plus 1 squared. And we've got some like terms, the 5x squared and the minus 10x squared. We could put those two together. So we'll have y prime is equal to, looks like we've got a 5 plus a 4x and minus a 5x squared. And this is all divided by x squared plus 1 squared. Okay, so there is our derivative using the quotient rule. Okay, let's do one more. Let's go with the derivative of the tangent of x. So the first thing I'm going to do, no, we don't want that. The first thing I'm going to do is rewrite the tangent function as sine over cosine. All right, so now we have a quotient, sine x over cosine x, so we can apply the quotient rule. All right, so derivative f prime of x, remember low d high minus high d low over low low, so low cosine x, d high derivative of the top, derivative of sine is cosine, minus high d low, so top sine of x, times the derivative of the bottom, derivative of cosine is a negative sine, all divided by bottom squared, cosine squared of x. Okay, let's do some simplifying here. Cosine times cosine, that's cosine squared of x. We have a minus minus, so that's a plus. Sine times sine is sine squared of x. Okay, so now in the numerator, we have the Pythagorean identity for trig functions. Cosine squared plus sine squared is equal to 1. So on top, we have a 1 divided by the cosine squared of x, and the reciprocal of the cosine function is the secant function. So the reciprocal of cosine squared is secant squared of x. So we now have a formula for the derivative of the tangent of x, and that is secant squared of x.